for a given set of data with proper choice of scales and error bars. Apparatus: a graph paper, plastic metric ruler, and a sharp pencil, preferably 2B. A graph is a pictorial presentation of how one quantity changes if another quantity that is related to it also changes. A graph can be used to 1. Communicate information regarding the dependence of one quantity on the other, and 2. Determination of the value of some quantity by finding slope or intercept of the straight line. Let us consider a set of observations made by an observer of distance d covered by a particle with time t. To plot a graph, following steps are taken. 1. Choice of axis. The quantity which depends upon the other quantity is called dependent quantity, and the quantity which does not depend upon the other quantity is called independent quantity. While plotting a graph, independent quantity is taken along x-axis, while the dependent quantity is taken along the y-axis. Here, the distance covered by the particle depends upon the time. Hence, time t is the independent quantity and is to be plotted on the x-axis. Distance covered is the dependent quantity and is to be plotted on the y-axis. Write the name of the physical quantity being plotted on that axis, its symbol, and the symbol for its unit. Let us draw the two perpendicular axes, x and y-axis, and write time t on x-axis and the distance covered d on y-axis. 2. Choice of scales. A suitable scale should be chosen to accommodate most of the observations. If the values of the independent quantities are having more spread than that of dependent quantity, the orientation of graph paper can be taken horizontally. Here, the values of t range from 0 to 4 seconds, and those of d range from 0 to 80 meters. Hence, let us take the graph paper vertically with time t along the breadth of the paper and distance d along the length of the graph paper. Since the data does not have any negative value, take the origin 0, 0 near the left corner of the graph paper. Scale for each axis should be convenient and easy to work with. One division on the graph paper and the unit quantity on an axis should bear to each other a simple ratio such as multiples or submultiples of 2, 5 or 10. Let us decide the scales to be chosen along x and y axis. The scale are such chosen to use more than half of the graph paper. The maximum value of the quantity to be plotted on x-axis has a value of 4 seconds, and there are 180 divisions. Hence, a scale of 1 division is equal to 0.05 seconds is appropriate. Similarly, the quantity to be represented along y-axis has a maximum value of 80 meters. There are 240 divisions along vertical axis. Hence, a scale of 1 division is equal to 0.5 meters is more appropriate. Write the scales in the top right corner. Scale on x-axis, 1 division is equal to 0.05 seconds. Scale on y-axis, 1 division is equal to 0.5 meters. 3. plotting of the point. Mark the data points with a small dot. Draw a small circle around the point such that the area of the circle represents the uncertainty in the measurements of these quantities. Error bars are also often used to represent variability of data or the uncertainty in the reported data. The more the spread in the data about the mean value, the larger the error bars. 4. Drawing a smooth curve. Here, all the points fall on or near a straight line. A straight-edge transparent ruler is used to draw a smooth, continuous line that comes as close as possible to all the data points. Under no circumstances should a zigzag line be drawn in an attempt to force the curve to pass through every point. 5. Giving a title to the graph. Give a title to the graph in a descriptive manner so that the purpose of graph is clearly understood. Let us give title to the graph drawn as Relation between distance traveled and time.